Okay, welcome back everyone into this last video of the first module where we're going to talk about different type of system modeling techniques. Okay, now system modeling in itself is quite a complex task to understand. So this presentation is all about that. I'm going to help you understand system modeling and what system modeling is. Since you're already coming from the topics of kinematics, this is going to be a follow along lecture. So if you haven't checked the previous videos out, I would highly recommend do that and let's dive into it. Yeah, now it's better. So, we are going to look at system modeling in this chapter, and that's what is going to be our main agenda. Let's look at the definition. System modeling is a process of creating a mathematical model of the robot or a system, which can be used to simulate and analyze the system behavior. Now, we already talked about kinematics in general. Now, system modeling is an extension of that, and this is a more generalized version of the entire system now. Okay, what we're doing is we are creating a mathematical model of every other parameter which is affecting the system. This can be any sorts of inputs, any sorts of physical parameters, any sorts of noise which is there, and all of these things are going to get modeled into the system so that we can measure them, we can understand about all these properties, and we can also figure out if there's a problem which is happening. Okay, so all of these system properties help us understand, divide, and figure out all these parameters for our future use case. Also, you can simulate a lot of parameters by adding different values, figuring out what would happen if the air resistance is high, what would happen if the friction is high, and things like so on. So system modeling plays a very important role, not just in robotics, but in simulation in general as well. And that's what we are going to look at. So system modeling is an important aspect of robotics as it allows for engineers and researchers to design and test robot systems before they are built. Now, the main idea over here is that you need to analyze all the systems before they are even built. Okay, you don't need to build them. Okay, before you finish or before you what do you call before you finish your planning, you need to try them out in a software simulation, and that's what system modeling or system modeling design helps you to do that. Okay, you're going to take all these parameters, you're going to analyze all of them, and then you're going to formulate an equation which is going to give you the idea. Okay, so there are several types of system modeling in use in robotics, including kinematic modeling. We already saw that a little bit before. Dynamic modeling and control modeling. Now, dynamic modeling is one of those parts which you would incur, not that much, because it's quite complex, to be honest. Control modeling is again one of the easiest one, easy one, not the easiest one. Modeling is always quite a tedious process. So yeah, let's jump into the kinematics modeling. We already did this. Kinematic models describe the relationship between the robot joint angle and the position of the orientation of the end effector. So we are focusing on the end effector. That's our main use case, and that's what we're looking at. Then you have types of system models. Okay, dynamic system models describe the forces acting on the robot and how they affect them in motion. Okay, this means when they are moving, okay, how does that affect the system? Okay, we're not talking about objects which are static. We're talking about objects which are dynamic in motion. Okay, so they're moving all the time. So you understand when an object is moving, mathematical calculation of that robot or the machine is going to be quite complex. Control models describe how the robot's control system adjusts the robot's behavior based on feedback from the sensor. We are already getting, and we are always getting the feedback from the sensor. We just need to continuously upgrade that system. And we need to figure out, if the system is powerful enough or capable enough to handle these situations. And that's what this model talks about. Then you have simulation of system models. Okay, this means that you are going to model and simulate different models in such a way, such as MATLAB or Simulink, so that the software allows you to look at them and look at such things in a much more easy or realistic way. Now, what does is that it's going to allow you to change those parameters dynamically when you're adjusting the system. So let's say you have a robot which is going to work on, let's say, sorting out boxes, but you have a different model now. Or if you have a different robot which is going to work on, let's say, packaging the boxes. Now, in that case, since both of the systems are quite close, you can just change the parameters of the size of the box and you can understand how this is affecting the system. Simulation allows engineers and researchers to test and refine their system models before building a physical robot. Now, you understand building a physical robot requires a lot of capital and it's quite expensive. So, simulation is the key. That's how we all engineers solve these issues. Simulation can also be used to evaluate the performance of the robot under different conditions, optimize the robot behavior. Optimization is quite an important task after you have a very good robot. And Essentially speaking, like all these robots require a lot of different kind of situation based analysis. So every time you put the robot in a different condition or different situation, it's gonna change quite a lot. Then you have advantages of the system modeling. Okay, system modeling can severely has several advantages in robotic, including the following. Let's look at them. You have cost saving. Okay, so essentially speaking, you're not building anything, so you are only and only spending time in simulating this thing. So you can do it on your laptop, you could do it on your workstation, you can do it these days. You can also do it on your iPad. I generally do it on my iPad because it's much more easier, to be honest. And yeah, there are obviously different softwares for different use cases, but a lot of softwares are also available on the iPad as well. So they allow you to engineers and researchers to test and refine their design before building a physical robot, reducing the cost and time required of development. Optimization. Then we talk about optimizing. So system modeling allows for optimizing the robot's behavior and performance, ensuring that the operation is efficient and done efficiently. Okay. So effectively and efficiently. So, optimization is again one of those element things which is very vague for robotics, because optimizing can be a very challenging task, when it comes to robotics in general. And when we say that, optimization of robots is important, it also means that it's going to be quite critical as well. Then you have safety, 110% very important topic of safety, because safety is one of the most critical thing. And if you're working with the physical robot, safety can be put into danger if the robot is huge. Now, when you're working with a simulation, it's going to be quite easy because, things won't really break. Only the software will break, and you can basically fix all the softwares in the software itself, and you're not really killing anyone. So it's quite a easy task to resolve. And then you have challenges in the system modeling. There are several challenges in the system modeling in robotics, including the following. One is the complexity. You understand, when we talk about your robots, it means that you need to have like a mechanical engineer, electronics engineer, and a software engineer knowledge for all of these things, and you need to know what exactly is happening. And that's where complexity comes in. Okay, so since the things are quite complex, it's not easy for everyone to do it. So robot system can be complex, difficult, and more difficult to model as well. Then we have uncertainty. Uncertainty derives from the fact that the robot system keeps on changing, and you might have different options, you might have different needs all the time, and it's very uncertain what you're going to build next with the robot. So uncertainty can be handled with the simulation in the robot. And then you have a verification. Okay, so system model must be verified to ensure that accuracy and accurately representation of the behavior of the physical robot. Verification can be challenging, as it requires comparing the behavior of the physical robot to the behavior of the predicted model. Okay, because let's say you need to verify if the robot is good enough. How would you do that? Okay, would you look at the time? Would you look at the power consumption, or would you look at something else? So verification can be again quite a challenge as well. In conclusion, let's revise what we did. We say that system modeling is an important aspect of robotics engineering, and it's better to simulate things before you actually build them. There are several types of system model used in robotics, including kinematics, dynamic model, and control model, which allows for all of these things to be done in a much more systematic and planned way. Simulation is an important tool for evaluating and refining systems, and it allows for cost saving, of course. There are also challenges such as complexity, uncertainty, and verification, which is a problem. But apart from that, I think simulation plays a very significant amount of role. Okay, coming back to the camera, that's it for us for this video. And we are also done with our first module. I hope you enjoyed, all these journeys so far, and you're enjoying robotics as well. In the couple of more modules that we have in upfront, we are going to look at how robotics and how all these concepts align pretty well, and how you can start making your own robot in different simulations and different environments, and how you can become a better robotics engineer. And I hope you are having fun, and I'll see you all in the next one. Till then, happy learning and peace.